Hello! Today's video is going to be a review on how to simplify radicals. So we see that there are two ways to do it. We can do factor trees or we can do perfect square factors. For 25 factor trees, we break this down. Yes, I know that you know what it is. But I break down my factor tree. The square root of 25 is just 5. When you have a matched pair, you have a perfect square. If there's nothing left over, then there's no radical left. So this is just 5. The square root of 25 is 5. I can do the same thing here, or I can use perfect square factors. So the perfect square factor method is, okay, I know the largest perfect square factor that divides 18. So I'm going to think about this as 9 times 2, because I know that square root of 9 is a perfect square. The square root of 9 is 3, with the 2 left over on the inside. So you can use factor trees, or you can use perfect square factors, whichever one you find to be easier. Factor trees sometimes I think is a little bit more work, but you're less likely to make a mistake. So if I break down 96, this is 3 and 32. This is 4 and 8. Oh, I'm not going to break down 4. Normally I would, but it's all about matched pairs make perfect squares. And I know there's going to be a matched pairs of 4s. And since I have a pair of 4s, the 4s go to the outside. I have a 3 left over and I have a 2 left over. If I had continued to break down those 4s as 2 and 2, 2 and 2, that's fine. I just would have brought 2 pairs of 2s outside, which still gives me that 4 answer. So when you're bringing out more than one number or you're leaving more than one number left over on the inside, those numbers get multiplied. So this becomes 4 root 6. Now we are multiplying. When we multiply radicals, it's all about location. Outside numbers get multiplied together. 5 times 3 gives me 15. And then I multiply the inside numbers together. 6 times 8 gives me 48. Now don't think that just because you multiplied them, you're all done. Now you have to see if you can break it down. So 48 can be broken down. 6 and 8, 2 and 3, 4 and 2, 2 and 2. I've got a group of 2s. Here's my other group of 2s. And then I've got a 3 left over. Now, one common mistake is forgetting about that 15 that was already there. Don't forget about that 15. So it becomes 15 that was already there. I'm bringing out one group of 2s. I'm bringing out a second group of 2s. And then I have a 3 left over on the inside. So it's 15 times 2, which is 30. 30 times 2. And my answer is going to be 60 root 3. With radicals, I not only multiply, but I divide as well. Dividing is when you have to rationalize the denominator. Rationalizing the denominator is getting rid of the radical on the bottom. If you remember what I said before, matched pairs make perfect squares. So I have a root 3 here. I can't have radicals on the bottom of my fraction. I want to get rid of it. So to get rid of it, I make it a perfect square. Matched pairs make perfect squares. That's why I want the same number, because now I have a pair of 3s. And the long way to see that is 6 is on the outside, 3 is on the inside, so 6 stays on the outside, 3 stays on the inside. Root 3 times root 3, those are both inside numbers, so that becomes square root of 9. But remember, we did this on purpose to get that square root of 9 because that's a perfect square. The square root of 9 is just 3. Radicals are all about location, location, location. If I'm trying to simplify, I can only simplify numbers that are in the same spot. I can't simplify the 3's because this 3 is inside and this 3 is outside. So it becomes 6 divided by 3. My final answer is going to be 2 root 3. Our next one, we're going to again rationalize by multiplying by whatever radical's on the bottom to get that matched pair. This time, 8 is on the inside. They're both on the inside, so I can multiply those numbers together to get the square root of 24. Root 3 times root 3 is just 3. If you need to go to the root 9 to the 3, go ahead, but we know anything multiplied by itself gets rid of the radical. But then I have to work on breaking down this 24. Well, I know it's 8 and 3 because that's what I multiplied. 2 and 4, 2 and 2. I have a 2 matched pair, so 2 goes to the outside. And I have a 2 and a 3 left over on the inside. So that gives me 2 root 6 all over 3. You can check to see if you reduce, but remember, it's outside numbers together, inside numbers together. 2 and 3 would be the two numbers that would reduce, and they don't. I can't reduce the 6 and the 3 because the 6 is inside, the 3 is outside. One more. Rationalizing root 8 times root 8. 2 is outside, 3 is inside. 8 is inside. So the 3 and the 8 get multiplied because of location, location, location over 8. We break down that 24. Oh, wait, we already broke down 24. So you can waste your time breaking it down again, or you know it's going to be 2 root 6. So here, this 2 gets brought down, and then I'm replacing the square root of 24 with 2 root 6. 2 times 2, 4 root 6 all over 8. When I go to reduce down, I'm going to be reducing the 4 and the 8 because of location, location, location. 4 is outside, 6 is inside, 8 is outside. So I need to reduce the two outside numbers together, which leaves us with the square root of 6 over 2. So that should all be a review. Now what is going to be new is something called the imaginary unit, imaginary numbers. If you remembered in the very beginning, we talked about real versus imaginary when we learned about rational, irrational, complex, all that kind of good stuff. Imaginary numbers, this should be easy to remember. Imaginary, we use an I for imaginary. We get imaginary numbers when we take the square root of negative numbers. So what I is representing is it's representing a negative 1. So if I want to change this, just so you can see where it comes from, if I change this to a negative 1 times 7, the square root of a negative 1, that becomes an I on the outside, and the 7 stays on the inside. So this is I root 7. So all that we're adding in here, all of the rules of radicals that you know are still going to carry over. The only difference is if there's a negative on the inside, you change it to become an I on the outside. So the square root of 4, we know the square root of 4, that's a perfect square, it's 2. But because of the negative, it's now 2I. If I break down 12, that's 4 and 3, 2 and 2. Group of 2's with a 3 left over. Because of the negative, it becomes 2I root 3 instead of just 2 root 3. So again, the only change is anytime you now have a negative on the inside of your radical, you move it to the outside where it shows as an I. Okay, that is it for today.